सो वेलकम बैक ऑन स्टेम बाबा। हम लोग चैप्टर पढ़ रहे थे लीनियर मोमेंटम एंड कोलिजन, and up till now we have completed 5 topics. The first topic that we discussed was linear momentum, then momentum and the Newton's second law. Then we discussed impulse conservation of linear momentum, and finally पिछले ही वीडियो में we discussed the topic inelastic collision. And today in this video we'll discuss some examples from this topic inelastic collision. तो चलिए बिना किसी देरी के शुरुआत करते हैं इस शानदार वीडियो की। So this is the first example, and here you can see this is a car and the mass of the car is given to be, let this be m1, which is 1400 kg, and it is moving with some velocity, say 5.3 meter per second along the positive x direction. And this is a truck, it is also moving along the positive x direction but with a speed of 3.2 meter per second. And let the mass of the truck m2, let this be equals to 2900 kg. And अब हुआ क्या, after some time the car collides with the truck and stick together after the collision, and we need to find that what would be the speed of the car and this truck after collision, and we can ignore the external forces. Okay, so this is a case of completely inelastic collision, because after collision the car is struck into the or sticks into the truck. So what we can write, that the energy is not conserved here but the momentum will be conserved. So the final momentum will be equals to the initial momentum. So what I can write, that m1 v1 plus this is the initial momentum for the car 1 plus this is m2 v2, the initial momentum for the truck. It should be equals to the final momentum of the system, which is the two masses we have to consider, m1 plus m2 multiplied with the final speed vf. Correct? And from here the final velocity, not the speed, you must say velocity here, not speed, because momentum is a vector quantity. So the final velocity, this will be equals to the initial momentum, that is mi vi plus m2 v2 divided by m1 plus m2. And this equation we studied in the previous video also. Now simply put the values. So mi vi, now here the velocity is along the positive x, so this direction I'm taking positive. So m1 we have 1400 kg, v1 is 5.3 plus m2 is 2900 kg, and this is 3.2 divided by m1 plus m2. So m1 we have 1400 kg and m2 we have 2900 kg. And after solving you'll get the final velocity to be equals to 4.6 meter per second. That means this velocity comes out to be as positive. That means that the after collision the truck and the car would be moving along the positive direction or positive x side. So from here we can see that the momentum was conserved but the kinetic energy was not conserved, because it is a case of inelastic collision. So इस case में some of the kinetic energy, some of the initial kinetic energy would have been lost in some other form, like heat, sound, या फिर permanent deformation के लिए जैसे जब भी metal to metal contact हुआ होगा यहाँ पे, तो कुछ the परमानेंट डिफॉर्मेशन आ गई होगी कार के अंदर भी और ट्रक के अंदर भी, तो उसमें भी कुछ काइनेटिक एनर्जी लॉस्ट हुई होगी इन डिफॉर्मेशन. Now if we want to discuss that how much kinetic energy is lost, then based on this question we'll take one more question, that how much kinetic energy is lost here and how much is left. with the system. So let's take one example on this. So this is the next example, and here you can see we have two railroad car. Both have the same mass. This one also mass m, here also the mass m. Now initially this car was at rest, so its velocity, initial velocity was 0, and its initial velocity was v. And after the collision, both the car stick together, and we need to find that after the collision what is the kinetic energy of the system as compared to the initial kinetic energy. So here this is a case of completely inelastic collision, and just now we studied that after collision the final speed of the two car would be the initial momentum divided by the total mass. So initial momentum for the two car would be, here this is m times v, here the velocity was 0, so no momentum, 0, so plus 0 divided by the total mass. Mass is same, so m plus m is 2m, so that would be v over 2. So after collision the car will have a velocity of v over 2, just half the value of its initial. So initial kinetic energy of the system, if this is half mv square, correct, this is the initial kinetic energy, then what would be the final kinetic energy? If I write the final kinetic energy, this would be half, the total mass would be m plus m, so 2m multiplied with the speed here is v by 2, so v over 2 and its whole square, which is equals to 1 over 2, this is 2m times v square over 4, correct, which is equals to 1 over 2 times 1 over 2 mv square. We can write in this way, and this is what the initial kinetic energy. So the final kinetic energy is half of the initial kinetic energy. That means exactly half of the kinetic energy is lost during collision. So precisely we can say that only 50% of the kinetic energy is left after collision, and rest 50% of the kinetic energy is lost in the sound energy, heat energy. Some of the kinetic energy is lost in deforming the shape of the two cars. So हम ये तो बता सकते हैं कि 50% of the kinetic energy is lost, but वो lost कितने परसेंट में कितना कितना हुआ है, मतलब कितना परसेंट साउंड एनर्जी में कन्वर्ट हुआ है, कितना परसेंट हीट एनर्जी में कन्वर्ट हुआ है, ये हम शायद ना बता पाए, बट एग्जैक्टली हम ये बता सकते हैं कि 50% of the kinetic energy is lost during collision. So this is the next example, and here you can see on a touchdown attempt, a 95 kg runner backs run towards the end zone with a velocity of 3.75 meter per second, and the linebacker moves at a velocity of 4.10 meter per second towards the negative x-axis. This is positive x. Now after collision, head-to-head collision, the two players stick together, and there are two parts. हमें दो चीजें निकालनी है. First, the final velocity immediately after the collision, and the initial and the final kinetic energy of the system. So first of all, you should know that what we are taking the system. System means these two person are our system, and there is no external force acting on it. So the momentum is conserved, and this is a case of inelastic collision because after collision the kinetic energy is not conserved, it is being lost. So what would be the final velocity? We can conserve the momentum. Momentum will always be conserved. So m1 v1, this is the initial momentum for this player 1, this is player 2, plus the initial momentum for the player 2 is equals to the final momentum of the system. So m1 plus m2 times vf, and so यहाँ से फिर से वही एक्सप्रेशन आ जाएगी जो हमने पिछले क्वेश्चन में निकाली थी, द इनिशियल मोमेंटम डिवाइड बाय द टोटल मास. बट यहाँ पे जो वेलोसिटी है ये ऑपोजिट है, सेम डायरेक्शन में नहीं है. पिछले वाले एग्जांपल्स में जो वेलोसिटी थी या तो वो ज़ीरो थी सेकंड ऑब्जेक्ट की, या वो सेम डायरेक्शन में था. तो इस क्वेश्चन में क्या है, दिस इज वी f, यहाँ पे square नहीं है, this is not square here. So final जो velocity होगा वो कितना हो जाएगा? That will be equals to, now m1 v1. So m1 we have mass I didn't mention. This player has a mass of 95 kg and this player has a mass of 111 kg, 111. Okay, so m1 is 95 and this direction is positive x, so this is positive 3.75 meter. Then plus m2 is 111 kg and this is towards the negative x, so I can write minus 4.10 divided by the total mass 95 plus 111, and that will be equals to negative 0.480 meter per second. And why this is negative? Because it's along the negative x direction. That means after collision the object or the system would be moving along the negative x with this much of magnitude of speed, 0.480. Correct? Now the initial and the final kinetic energy, it's pretty simple. Initial kinetic energy, this will be half m1 v1 square plus half m2 v2 square, and after putting the values you'll get this kinetic energy to be 1600 joules. And what would be the final kinetic energy for the system? So 1/2 m1 plus m2 times vf square, and अब जब values put करेंगे you'll get 23.7 joule. That's shocking. You can see that about 98% of the kinetic energy is lost. And the kinetic energy lost किस में हुई है? It is lost in some other forms of energy like sound, heat, friction, deformation. तो इन चीज़ों में kinetic energy lost हुई है. But still the interesting thing is the momentum is conserved. Momentum is not lost here. The initial momentum is equals to the final momentum. This is very interesting. Even after even the kinetic energy is not conserved, but the momentum will always be conserved with the condition that the net forces on the system is 0. Then only the momentum will be conserved, which is in this case the net forces is 0 on the system. So it was a great example. Let's see a couple of more examples. So this question is based on ballistic pendulum. It's a very interesting question and it has a very physical significance in our world. So let's try to understand this. So here we have this bullet of mass m traveling with initial speed vi, and it is being hit on this pendulum, the bob of this pendulum of mass capital M. Now after the collision, the bullet is embedded in the bob and then the bob gains some height h. Our aim is to find this height h in terms of small m, the mass of a bullet, capital M, the mass of bob, vi, the initial speed of bullet, and g. In these terms we have to find this h. Now here in this problem involves the operation of two separate physical processes. First, पहले क्या हो रहा है कि जो ये मास m है, जो बुलेट है, it gets embedded into this. So it's a collision and it's a completely inelastic collision. Next, the kinetic energy that the system have at this point is being converted into the potential energy. So first we're going to find what is the speed at this point after the collision. What is the speed? And for that we can use the conservation of momentum. And then after this point, after the collision, the kinetic energy is converted into potential energy. So for this we can use the conservation of energy. So two separate processes we're going to use. So first let us try to find the final speed of the system. So what we can use the conservation of momentum. So the initial momentum of the system, this was the initial system, initial position. So initial momentum will be equals to the final momentum of the system. So initially the bob was at rest, so its momentum would be 0, and the bullet is having speed vi. So what would be the momentum? mass times Vi, correct? Then this will be equals to, now after the collision, the bullet is embedded into the bob, so this mass, the total mass for the system becomes small m plus capital M, and its velocity or becomes Vf we are taking, so Vf. So from here the final velocity, this would be equals to m over capital M plus m times Vi, correct? So at this position we have found out the velocity. Velocity is basically it's along the positive x. Okay. Now from this point to this point, the kinetic energy is converted into the potential energy. So we can use the conservation of mechanical energy. So I can write that here the initial kinetic energy we have, and this is the final potential energy. Initial kinetic energy we have half. Mass is m plus capital M. V square means this thing square. So m divided by m plus capital M, and its Vi, and then its whole square. And this is equals to the final potential energy. At this point, the kinetic energy becomes 0. So the potential energy for the system would be small m plus capital M times Gh. Simply we have just used the conservation of mechanical energy and we obtained this expression. Now इसके बाद हम क्या कर सकते हैं? H का expression यहाँ से निकाल सकते हैं. This thing and this thing will cancel. तो मैं G को यहाँ ले जाता हूँ. तो ये हो जाएगा v square divided by 2g times small m divided by small m plus capital M is equals to h. So this will be the height h of the system. Now this is basically what? This is example based on the ballistic pendulum, and why this ballistic pendulum is used. And the ballistic pendulum is mainly used to find the initial speed of the bullet. If manually we are able to calculate that what is the height h we know, small m the mass of bullet we know, the mass of bob we know, and G is a standard value, we can find Vi. This is the main physical significance or physical practical application of the ballistic pendulum. Other way around, if we need to find the speed of the bullet, what we can do, we can fire the bullet in the upward direction like this, and at some height this will going to stop. And in our previous questions or previous chapter, we have find out that this h will be equals to v square over 2g, just by using conservation of energy. But in this case this height would be very much high, but in this case this height would be less because this capital M is very much high as compared to the mass of the bullet, and we can easily find this velocity Vi. कहने का मतलब दो अलग अलग तरीके हैं. आपको अगर स्पीड निकालनी है बुलेट की, तो आप सिंपल हवा में वर्टिकल डायरेक्शन में बुलेट को फायर कीजिए, वहाँ से कुछ हाइट h निकलेगी जिस पॉइंट पे जाके जीरो हुई होगी उसकी वेलोसिटी, बट वो हाइट काफ़ी किलोमीटर ऊपर जाके हाइट जीरो होगी, मतलब उसकी वेलोसिटी जीरो होगी, तब जाके आप ये इसकी इनिशियल स्पीड निकाल पाओगे. बट इस केस में हम क्या करते हैं कि जो मास ऑफ बॉब है इसको हम बहुत ज़्यादा रखते हैं एज कम्पेयर टू द बुलेट, द मास ऑफ बुलेट. तो क्योंकि ये वैल्यू बहुत ज़्यादा होती है, डिनोमिनेटर बहुत ज़्यादा है, तो ओवरऑल जो वैल्यू होती है एच की ये काफ़ी कम आती है, कुछ मीटर में आती है, तो हम इजीली मेजर कर सकते हैं. तो ये है इसका प्रैक्टिकल एप्लीकेशन. Now we'll see one more question on this inelastic collision, which is inelastic in 2 dimension, and then we're going to end this video. So यार ये question है inelastic collision पे, but it is in 2 dimension. तो यहाँ पे क्या हो रहा है कि one car is traveling along this direction, let this be positive x, this be positive y. तो positive x की तरफ move कर रही है with a speed of 16 meter per second, and इसका mass हम लोग ले लेते हैं 950 kg, and let the mass for this car to be 1300 kg, and इसकी जो speed है this is 21 meter per second. So let this is m1 and this has mass m2, and our aim is to find the final speed of the car after collision, and it is given that after collision the car stick to each other, stick together basically. So what we can use? We can use the conservation of momentum इन x एंड y डायरेक्शन सेपरेटली, क्योंकि यहाँ पे x डायरेक्शन में मोमेंटम अलग से कंजर्व करके देखेंगे एंड देन y डायरेक्शन में मोमेंटम अलग से कंजर्व करेंगे. सो व्हाट आई कैन राइट, द मोमेंटम इन द x डायरेक्शन, द इनिशियल मोमेंटम इन द x डायरेक्शन, दिस इज इक्वल्स टू द फाइनल मोमेंटम इन द x डायरेक्शन. दिस थिंग व्हाट वी कैन राइट. नाउ इनिशियल मोमेंटम अगर मैं देखूं तो देखो इस कार के लिए तो x डायरेक्शन में कोई मोमेंटम है ही नहीं, तो इसको तो जीरो हो जाएगा. अच्छा इसका है एंड दिस इज अलोंग द पॉजिटिव एक्स, तो मैं सिंपल लिख रहा हूं m1 इंटू v1, करेक्ट, इज इक्वल्स टू. नाउ फाइनल मोमेंटम आफ्टर द कोलिजन, द मास फॉर द कार बिकम्स, फॉर बोथ द कार बिकम m1 प्लस m2. अब देखो हमें वेलोसिटी का कंपोनेंट देखना है अलोंग द एक्स डायरेक्शन, तो वो क्या हो जाएगा vf कोसाइन थीटा. Now next अगर मैं momentum conserve करूं in the y direction, so what I can write the initial momentum in the y direction, this will be equals to the the final momentum in the y direction. Now अब इस केस में क्या हो रहा है कि एक y डायरेक्शन में इसके पास इनिशियल मोमेंटम कुछ है नहीं, क्योंकि ये तो पॉजिटिव x की तरफ मूव कर रहा है. बट अगर मैं इस वाली कार की बात करूं this one, तो it have a positive momentum in the y direction because it is moving along the positive y. तो मैं क्या लिख लूंगा m2 into v2, we can write this way. v2 हमने ये ले रखा है इस डायरेक्शन में. फाइनल क्या होगा m1 प्लस m2. अब देखो इसका जो है हमें y कंपोनेंट की तरफ देखना पड़ेगा, तो वो क्या हो जाएगा vf sin थीटा. तो अब अगर मैं इसको इक्वेशन नंबर 1 बोल दूं, इसको इक्वेशन नंबर 2 बोल दूं और दोनों को डिवाइड कर दूं, 2 डिवाइड बाय 1. सो व्हाट आई कैन राइट दैट, यहाँ पे देखो साइन थीटा ऊपर रहेगा और कॉस थीटा नीचे रहेगा, बाकी ये दोनों टर्म्स कट जाएंगे आपस में. तो अपने पास क्या बच जाएगा, यहाँ पे टेंजेंट थीटा बच जाएगा और इधर क्या बचेगा m2 v2 डिवाइड बाय m1 v1. अब अगर मैं वैल्यूज पुट कर दूं तो मैं क्या थीटा की वैल्यू इजीली निकाल ले जाऊंगा, बिल्कुल निकाल ले जाऊंगा. दिस इज टेंजेंट इनवर्स और ये हो जाएगा अपने पास m2 v2 हमें पता ही है 1300 इंटू v2 इज 21, देन 950 मल्टीप्लाइड विद 16 विच इज इक्वल्स टू 61 डिग्रीज. सो जो ये एंगल होगा ये कितना हो जाएगा 61 डिग्रीज. अच्छा स्पीड कैसे निकालेंगे, यू कैन पुट द वैल्यू ऑफ थीटा इन ईदर इन दिस इक्वेशन और ईदर इन दिस इक्वेशन. यू कैन फाइंड द फाइनल स्पीड. सो vf की जो वैल्यू आ जाएगी दैट विल बी इक्वल्स टू 14 मीटर पर सेकेंड आफ्टर पुटिंग द वैल्यूज. तो ये तो हो गया हमारा क्वेश्चन, हम लोग कैसे सॉल्व कर सकते हैं व्हेन द we have 2 dimension problem, the inelastic collision in 2 dimension. So with this we have discussed all the possible examples related to inelastic collision. Now I'll be giving one practice problem to you that you have to solve on your own, and this is the problem. It says that two objects travel in an opposite direction along a straight line. So we have two objects traveling in the opposite direction, means this is traveling towards this side, this is traveling towards this side. They have equal momenta of equal magnitude and they stick together when they collide. So after collision ये दोनों stick कर जाते हैं और momentum इनका same है, इसका भी p है इसका भी p है. So what percentage of the initial kinetic energy is converted to form as a result of collision? तो देखो initially कुछ kinetic energy रही होगी इनके पास, सिस्टम के पास. सो आफ्टर कोलिजन जो फाइनल काइनेटिक एनर्जी होगी वो क्या होगी. सपोज इसके पास इनिशियल काइनेटिक एनर्जी कुछ k रही होगी, इनिशियल k ऐसे इतना ही रही होगी, तो जो फाइनल रही होगी वो ki की टर्म में कितनी होगी. दिस इज व्हाट वी हैव टू टेल. तो ये आपको खुद से करना है based on the question that I have discussed earlier in this video. We can easily answer this question. So with this I'm going to end this video, and in the next video we'll start a very interesting topic on collision, which is elastic collision. So अपना बहुत ही ख्याल रखिएगा. Goodbye.